Hey guys, how is everybody going? How is everybody doing, rather? So, this time I went ahead and. Uh, can you hear audio? YouTube's complaining again. I'm pretty sure you can, though. So, this time I put the latency back to low latency instead of ultra low latency. Hopefully, that works a little bit better. Because last time it did have the buffering issue. Hopefully, we don't this time. How's it going, Marius? Old Dugu, Oldugu. How are you doing? Hey, Ahid. Hey, Daniel. So, what I have for I don't understand like YouTube streaming. Like I literally have suggestion. The audio stream's bitrate 0 is lower than the recommended bitrate. Like I don't understand these warnings. It's why I ask so much about audio because it just gives me nonsense. So as you can see over here, I have the linear rails and I have a new camera setup so I can actually kind of go through and show you what I have, and it doesn't just have to be my face, which is cool. I also have a other camera behind me, but I don't have that fully set up, but it is what it is. How's it going, Tin Fever? So I'll go ahead and just kind of wait a second till everybody gets here, but yes, whoever, it's been a few weeks because I wanted to make sure that I had everything. I think was it Tin who recommended the Fuyu linear rails? Whoever it was. Yes, I definitely would recommend them. They are super, super well built for the price. Like they are really, really durable. And I have the step files for the actual actuator. So it was Tin. Okay, got it. That's what I thought. So I have the step files for the two different sizes of the actuators. I was able to get them from the manufacturer. I also have I asked them about the step file for the mount, but I didn't realize the person responded back with a question of which mount I wanted, and I never responded until 20 minutes ago. So I don't have those mounts, but it's going to be pretty easy to build them. Now that I see how it mounts, it's pretty self-explanatory. Links, yes, give me a second. I will. That's probably a good idea. I should post the links. I think I have like $500 all said in the three, somewhere in there. Which, with how well these things are built, that seems like a pretty stellar deal. Okay, so this is the 400 millimeter, and this is the 200 millimeter, the 100 millimeter. Two of these. So 150 for the 100, so 300 plus the 182. So yeah, what, 482 bucks? I don't know what that is in Finland-ish monies, but that's what it is in USD. How's it going, MSCNC? Yes, very glad that you are able to join. So, what I am thinking we will do is, hang on one second. So, I'm thinking we'll do is just kind of start mocking up kind of the basics of the gantry system, not really getting like too much into the details. Yes, I do have the new toys. And yeah, I don't know, you probably weren't here right at the start. So yes, I definitely, at least as build quality goes, I definitely recommend these. They are like unbelievably sturdy, like shockingly sturdy. Yes, I knew USD was the same as a euro right now. I did not know if there was going to be any like taxes or the VAT that you guys have to pay depending on where it's shipping from. That is what I was referring to. One thing is they do not play around with greasing these rails. There is like white grease or clear grease on like everything, on the connectors, on every single part. So yeah, I think like I said, we are ever yeah, I would love to come on a holiday there. No kidding. That would be pretty awesome. So yeah, start kind of just building out this gantry system and then kind of go from there. But one thing, and I've been talking to Marius a lot about this. So I had mentioned in the past that like end game, I'd love to build like a pick and place, mainly just for fun, because I think that'd be a really cool project, pretty difficult, or at least more challenging than this. But after talking to him, I think there are some ways that it could actually be pretty useful for like prototypes and one-offs. So I'm like super, super excited about working on that. So what I'm probably going to do is this is going to just be like getting my feet wet, because I don't really have any gantry or motion system experience on the mechanical side. So just kind of use this as like the introduction for me, kind of figure out what I know and what I don't know, and then jump to building the pick and place after, which I am like really, really excited to do, because I think we have some really cool ideas with it. So that's just kind of the gist of it. And also, if you guys haven't already, go ahead and check out Marius's channel. It's pretty new. He doesn't have a ton of stuff up yet, but he's going to be working on a lot of neat stuff coming up. It's a lot of like motion systems. He's working and has built and is selling these really cool USB-C adapters for PlayStation controllers, which are pretty fantastic. So yeah, if you're interested in like kind of this type of project and similar electronic similar electronic stuff, definitely check out his channel. And a lot of what I'm talking about is either directly from him or heavily inspired from him. So I cannot take much credit for a lot of this. So let's jump over to Fusion 360. And also, so these are the gantry pictures that the person from Fuyu sent. So obviously we're going to be running with this one, and the way that the mount works, I believe, is there are just two. So actually, let me show this again. So on the underside of these, there are sliding nuts on both of the tracks, and there's a bunch of them. So my guess, God, these things are heavy. My guess is the way that these work is, since these mounts stick out past this, is there is just two holes there that a bolt threads through this and then threads into those nuts, and it just slots in right there, which makes the rigid mount. I'm assuming, I think that's pretty much the only way it can be done. And that's going to be the way that I plan on doing it here, which I'm pretty sure a couple of you guys had mentioned last time that that's how they were doing it. But yes, I wish I would have, just for completion's sake, would have gotten that info from them rather than just kind of making an assumption, but it is what it is. So what I'm going to do first is just kind of make a, just kind of to simulate the flat floor. Why did it do that? Why did it make those? What in the world just happened? I don't exactly know why it's doing that, but I guess we'll do it this way. That's pretty funny. Oh, these are not all fixed already. Whoops. Rigid group. And just to state the obvious, I am obviously no expert when it comes to especially Fusion 360, so feel free to call me out on things that I'm doing probably very poorly, but we should get it done one way or another. So that one's good, that one's good. Oh, they're all good. Okay. Okay. Actually, let me move them off here. MSCNC, what CAD software do you typically use? Do you use Fusion 360? I know their CAM tool's pretty good. At least it seems like a lot of people use those. Okay, that's not rigidly mated. Mostly Fusion 360. That's cool. So are the others at least? Oh, this is a stupid thing with Fusion. It'll show that it's just those, even though it's not, I think. We'll find out. Yeah. See, that's something that Fusion does that's just really annoying. Oh, did I make that rigid? Whoops. Because it's like, it should know that these are already all mated together instead of just showing the one, which is kind of annoying. Yeah, I'm way more comfortable with SolidWorks. That's what I did all throughout school, and that's like what our certification was in to like pass the class. Whoops. Did I do that one? Because honestly, I think one of the biggest weaknesses of Fusion 360 is how it handles joints as a whole. I think is really bad. Like the way it forces a snap point on everything. Why is it forcing it like this, though? Oh boy. This is going to be a fun one. Because it's like if you're doing just a single planar joint, it should not force you to have that snap point. It should let you do that as a separate one. You can create a sketch with points and snap joints to those. Yeah, but the problem is I was trying to just get them all planarly mounted on here and then do the distances as a separate reference on here. I mean, I know I can do that. Yeah, I mean, I guess I can try. Let me just, I don't know why this isn't letting me at least make this. I guess maybe do it there. There, I guess that worked. And now let's do... Because it's like it forces you to do that reference even though the way I'm doing it isn't actually mounting to that reference. Because then I just click. Oh, it is forcing me, which is annoying. Because it still lets me move it, which is kind of funny. Okay, so that's... Oh, that's actually not going to go there because we need to have the bracket. So I guess we can work on the brackets now. So my guess is, because they have it, what, overhanging this way. So basically we just have something like this. How's it going, Zihaz? If you're creating the joints in floating mode, that will allow for motion. As a result, you'll be able to freely float them around. Yes, that's what I am. That's at least what I was going to, or going for. Coincident. I sometimes feel like Fusion 360 is a bit of a cult. People make it sound like you can literally do everything, and that I nearly went insane until going back to SolidWorks. Single joint is full strength. Yeah. I will say that compared to SolidWorks, for doing quick stuff, like this type of stuff, to where it lets you build the components within the main file, it is so much faster than SolidWorks. Because SolidWorks, you obviously have to have the separate file for each part, which for large assemblies is the much better like methodology to do it. But for like quick stuff, it takes a lot longer. So it just kind of depends on what you're going for. Okay, so let me actually, I'll make this a component so I can just duplicate it. And then like that's also funny. Sometimes it lets you build a component from an extrusion from that menu. Other times it forces you to do it from this. And it's like there's no real rhyme or reason, at least that I can see, to why that is. Yes, you can do in-context parts, but it's still faster the way you do it in here where it's based directly on the bodies. At least I found it a lot quicker to do it in here. What do I call this? Bracket. Okay. I prefer to create a new component first, then build a joint between new component and reference board. Yeah, like I said, this is not my forte, so I am certainly not going to be one to saying the preferred way to do it. Now, if we were doing something in a electronics CAD software, that would be a different story. Okay. So now, after that, it's not fair to compare SolidWorks with Fusion. Inventor is their professional level software. Fusion, they generally give out freebies. So, the only reason I compare it to is what I had said earlier, is I have 2 years of training while at my university for SolidWorks, and I have absolutely no formal training in Fusion. So for me, it's a fair comparison simply because it's a pretty apples to apples comparison. It's what I know. But yes, of course, there's absolutely no way you can compare. And like for my company, I can easily swing a Fusion 360 license, but there's absolutely no way I would ever be able to swing, nor would it make any sense, a SolidWorks license. So yeah, I can't really say I have any real complaints about Fusion 360 because the price is so amazing. So this is how I typically do the joints to keep them parallel. So now I can adjust. If I need to come back and adjust the joint, I'll just adjust them from here. But that is an interesting thing you were saying, CNC. There's no quick. I guess I'll just start calling you MS. But I will try doing the sketch way and then mating it to that joint or mating it to that line. That seems like a pretty smooth way to do it. I could be more understanding on Fusion 360 if people on Reddit didn't mean. Yes. The one thing that I say is if you're doing a ton of components, 100% SolidWorks is better, no question. For stuff like this, like I said, I came directly from SolidWorks to this, and I found it's been a couple years. It's been like 4 years since SolidWorks, so I don't remember a lot of the quirks I had, but I do know that when I was starting on Fusion, I was able to do things faster than it would be in SolidWorks, so there's that. But I honestly don't really remember exactly what it was and why it was. Okay. Let's... Oh, that's not the angle I wanted. But I do remember, coming from SolidWorks, the thing that drove me crazy is the way that you did joints on Fusion was terrible. So, like, yeah, I mean, this is how I do stuff like this. And I know since I rigidly jointed these, I don't have actual motion in the gantry. Yeah, exact. That's what I was just getting at, is I don't have the ability to make everything move like that, except, or I mean, not except, I don't. But for stuff like, oh, you know what I just noticed? They don't have the motors modeled in these. That's funny. I guess it doesn't matter, but that's kind of funny. But yes, I definitely don't have kinematic motion, which, I mean, for this, I don't think it matters that much, especially just doing it quick like this. What I'll also normally do is do it the quickest way possible like this, and then come back later and then do it correctly, keeping all the motion and everything. But for just getting something in the gist of it, I think it's fine. So now I'll go ahead and just mate all, oh crap, rigid group. Now I'll go ahead, yes, and mate all of these together. So we do have no motion, and now they're completely constrained. So it is what it is. It'll work. Okay, so let's center it-ish on here, which obviously doesn't matter. It's just super arbitrary. And now we can capture that and then rigid group this to, oh, whoops, that's not a component. Oh yeah, as built would have worked also. Good point. Okay, there we go. Now it's all fixed. So, and just to state the obvious that I'm not really oh, and that's not even centered. Whoops. So then the way I envision that this bracket will work is just having a hole here, or maybe a hole here, hole there. So 4 and 4, and then a bolt just threads into the nuts that are in here, and then that's what holds it. So the bracket is assembled first and screwed down, because let me switch. So the 4 holes right here that are big, they are not obviously threaded. I don't know if you can see because they have a screw in it. The small 4 ones are threaded, so you would be able to just thread down that top plate to this and then attach the bracket on the top side. Hey, have you seen the Strange Parts video of a small PCBA? Around video 4, you can see a small stencil printer, which looks to be, no, but let's check it out, because we're kind of at a stopping point anyway before we go on to the next part. But yeah, so that's how the bracket will work. And now I guess just so this, we can, because we obviously want this to be pretty much as wide as possible. So it'll be kind of like that-ish. Oh, it's off screen. There we go. Oh, and also, how's it going, Gabe? Gabsy? Haven't seen you around here. Okay, let's do back to here. So let's... was it one of these? Or which one? Because we've got a lot here. we'll try this one, 4 minutes. Not this one. Oh, this is the assembly one. Got it. This still looks like it. Fifth down and said small Chinese. Got it. You said 4 minutes. God, this is pretty sketchy. Okay, let's see. Okay, so it's got an automated... Okay, so it still has manual adjustments. So I'm really glad you mentioned this. So this is what's really funny about a lot of the semi-automatic stencil printers is almost all of the semi-auto printers are like this, to where you still manually adjust it, but it has the squeegees and the squeegee pressure automated, where this one's going to be opposite. And Marius will have, he's working on one right now that is this, where it has the stencil, the squeegees automated, which I don't know. I've never had a problem with the hand stenciling. I get it's important to have the pressure and everything because that's how our big printer does it, but I would rather have the alignment and the feeding of the board automated. Yeah, it's the manual little micrometer adjustments. And then this also, which is nice, has the fully parallel lifting of the stencil off, which is one of the key things. Oh, and she is not using gloves and is putting her hands all on as she pushes down. Yeah, that's not great. Oh, and he is rubbing the... Okay. They do not care about oils getting on the PCB. So these are the guys that when you get your PCB sometimes that have a big old nasty fingerprint on the center which starts to corrode all the pads. It must be from these guys. Oh, that's bad. Oh, she with a beard? Whoops, I thought the first one was a girl, my bad. Though you never know. I was hoping they would show... That is really bad how they're just completely rubbing that board. Are we going to show how it dropped? No, so he spent that whole time just talking about the board and the printer, but not actually showing it work. Oh, here you go. That board has like 4 parts on it. Yeah, so it has the... That is a really fast speed. Yeah, and it's not even doing a clean swipe. It's leaving tons of streaks. So yeah, sketchy PCBA. I would agree. But cool, yeah. Glad you brought that up, or glad you mentioned that, because it's interesting how this alignment side that I'm working on is kind of the opposite of what everybody else does. So now the next biggest thing, or I guess honestly the biggest thing here, is now figuring out the motion side, or the rotation. So whatever we end up doing for the rotation, just to kind of make sure we're on the same page, I envision, and again, this will be on top of the whatever is doing the rotation. So just pretend that this plate can rotate. So we're going to have some sort of plate here that holds the PCB on it. And I'm hoping or assuming that with how rigid, oh, you can't see really, oh yeah, you kind of can see what I'm doing. With how rigid all of this is, as long as this is like an aluminum plate or something, I don't think there's going to be any flex whatsoever. So I think we don't need any sort of rigidity supports here, but I guess we'll see. And if we do, then we can obviously just have a post going down here that when it starts to press down with the squeegee, it acts as a rigid support. But yeah, just wanted to get that out, that's kind of where my head is at with that. Maybe the idea behind that printer is not so bad, actually. Seems to have the fixture with the mount's positioning. However, for one-shot jobs, it's too much hassle. Yes. Again, like I said, that's how all semi-automatic stencil printers are. I think that they're great, and they obviously work great. I just think for what I want this for, what I think we'll be using it for, this alignment is going to be more useful. But maybe I'm wrong, and it's just going to be good practice with the gantry systems, which, like I said, will be useful for the pick and place. So, Win DIY selective soldering machine. I'm working on a project that will probably have several hundred through-hole joints between all the connectors. Yeah, our selective solder, that thing, it works. I don't know, can you see it? It's this machine right there. So you load the boards in there, it does its magic, and then they pop back out, and it's vented outside through there through a filter system. But yeah, that thing is a beast. It works great. It's just talk about a very long setup process for each job. That thing is really painful to set up. But yeah, so now I kind of forget where we left last time with how we're going to do the rotational, the theta adjustment. I know we had some people post last time after the stream about some rotary tables, so let's see. And obviously, if you have any other good ideas while I'm looking at these, let me know. Yeah, this was the one that looked really interesting. But the issue is with these, if we don't have a step file. Oh yeah, that's real nice. And it's flush with that. I was going to say make sure that doesn't stick up. I mean, that seems pretty good. How many joints before it makes sense? So we did an assembly job a couple weeks ago. It was 200 boards, and it had 3. It had 5 joints. So it was just a single potentiometer. So that's 5 joints times the 200 boards. So figure 1,000 joints, and we did that by hand. I would say maybe double that, and it would make sense to use it somewhere in that range. This is like 300 and change, I think. But Robot Dig, oh, it's on the mobile site. I was going to say, why does it look like absolute crap? But isn't this this comes from China, doesn't it? So this is going to be just as sketchy as eBay, right? I could be, oh yeah, Robot Dig, Shanghai. Unless, do they have parts that come directly from the US? Has anyone ordered from them before? Is there like an About Us? Yes. Robot Dig, Shanghai. Do they have US? No, it does not look like it. So this will ship straight from China, which I obviously want to avoid just because that's an utter pain. God, but these look super nice. Let's see if Amazon has anything. Or let me just, whoops. Amazon does, but is it Amazon Prime? No, it is not, so it's still coming from China. Fantastic. The other day was a cheap manual rotor table with hacked-on stepper motor. Yeah, I think that this, if we can find it somewhere that's not coming from China, that would be awesome. So let me just use the same keyword and see if there's anything else. Ah, so that's it. Crap. Man, and that seems like a really good fit, too. But I have no idea what the differences are here. So that's just the... So it's the gear ratio and the diameter, but all of these in the drawing show that it's fixed. Are there any that are variables? Not that I can see. Oh, what was that? A lab jack lifting machine. What? That's pretty funny. Okay, so see if we can find anything else. Because I get the idea of doing the a manual lathe rotational table, but I am really trying to avoid that just because with this being just kind of a proof of concept thing, I kind of don't want to go crazy with custom parts, at least not off the bat. So I'm hoping to find something. It's just the only thing that we had been able to find seemed to be microscope stuff, which is stupid expensive. I'm really surprised that that's not somewhere on Amazon or somewhere in the US. So this is a stepper motor that has a manual adjust on the back. Has anyone seen those before? That's kind of wild. I mean, it obviously doesn't work when it's powered. It's either or, but that's kind of cool. I mean, this is more expensive, but I guess it's not too terrible. Oh, upgrade to high torque motor. We definitely need that. Does it have a step file? That would be nice. Oh, IGS can... I don't know if Fusion can do that. Let's try. We have some rotational servos in our boats. Let me see if I can find a part number. I am going to guess that will be quite a bit more expensive, but you never know. Yeah, it seems like I can upload it. And the reason I just scroll this off to my other screen when I do this is because to do any of the downloading or uploading, I have to open up my file explorer, and I can't obviously share. This is my work computer. A lot of the files and stuff that pop up. Oh, hey, Sion, how's it going? It's early over there. How's tomorrow looking? Better than today? Tomorrow is cold but looking promising. Oh yeah, you guys are in your winter summer while we're in our winter. All right. Oh, this is like a perfect size, it looks like. That is nice that all of these parts are completely independent. Makes it a little bit of a pain for, again, just mocking these up really fast, but It's pretty cool. Kyle, look at YouTube videos channel on Discord. Guessing by the way you said LOL means that my hunch that it was quite a bit too expensive is probably right. Yes, I think the servo to adjust the engine, the motor of a boat on a jet drive or a whatever they're called is probably going to be a bit more expensive than I'm looking for. That would be a really, really powerful stencil printer, though. It could be like, I could try to start selling it and be like the world's most powerful stepper motor or the world's most powerful printer pod drive. That's what I was trying to think of. Man, does anybody have any objections with this? This looks pretty slick. The only objection I have is the price. But, you know, what is money when it comes to building something that probably will never even be useful? Let me demo it. Just stick your hand down in there. Yeah, no kidding. Seems tall. I was thinking that, but does it matter? Because I have a table that's pretty much dedicated to this. I mean, I guess the only thing that could matter is the z-axis, but if I don't want to pay for a super expensive or tall gantry, I can just build up a base around it. So I don't think that actually matters. Is there something else you're thinking why it might matter? Why is it not letting me drag this off? There we go. Oh, so the gear's actually not that expensive. That's funny. The higher it gets, the bigger the forces twisting the whole assembly. The bigger the forces twisting the whole assembly. Not twisting, bending. I see 100% now what you're getting at with it bending everything, because the higher it is, the more the bending moment is on here. If that's what you mean by twisting, then yes, point taken. Yeah, leverage, got it. I'd rotate it to have the stepper on the rotator table. Oh yeah, then it isn't cantilevered. Good call. Let me try it with that. Oh, that worked. And that's like another thing that's annoying, is it's like when you adjust it to move components earlier, I kind of wish it would stay rotating components, but I guess it is what it is. Not that big of a deal. The servo is bonkers, though. Could be a bit faster. Yeah, those jet drives, I remember when they first came out, they were super cool. Now it's like everything is using them. So this makes it so it's better centered just chilling, but to MS's point, which is if we have our mount, which is basically, although let's keep this in perspective. I'm gonna have to use inches for this, sadly. So a 6-inch PCB, because we're really not going to have panels on this. A 6-inch PCB is going to be about max for the vast majority of jobs that we're doing. Yeah, I mean, it is, but Yeah, I mean, I guess the height issue comes more from, like, the bending comes more from the height of the assembly, from the rails, more so than from this. I think it is what it is. I mean, yeah, it could be thinner, but I don't think that's going to be the end of the world. Let me know what you guys think. I think this is totally fine. Because, again, that's going to be about max that it'll ever be, size-wise. How much downforce from the stencil and squeegee are we talking about? I think it would all be straight down to the center, everything right. Yep, 100%. And like I was saying, what we can do, you know what? Instead of what I said earlier where we have pegs supporting this, oh, good point. I don't even know how tall it is. Oh boy. Why is it not wanting to select that? 207 millimeters. Again, sadly, go here. 8 inches. That is getting pretty tall, to be fair. But here's what I think we do, which I did not think about until just now. So, let's say, what's the normal small size stencil? Oh, you were thinking it was even taller. I forget what the standard small stencil is. So let's say 470 by, because this is the normal one we'll run with. So do 370, 470. Oh, that worked well. How big did I just make that? That's a big stencil. Why is it not letting me tab? Oh, because I didn't do it when I started it. Whoops. I don't see the bending issue. The only thing I see unsupported between the Lua and... So, Tin, I think regardless, I have the solution for this, and I think this is a smart idea no matter what. It's something that me and Ahid were kind of talking about on the last stream a little bit. So I guess, let me just do... Make it accurate. 0.12. And then let's do... easiest way is project, and then offset. I think that's an inch in normally. It's an inch by a half inch, I think. So 0.5 inches. So this is how it'll look. There you go. MS. Yeah, that's exactly what I'm working on right now. So instead of doing the support pillars under where the PCB is, which I think, as Johnny said, is going to be plenty strong, instead what we should do is something like this. They would be in collision mode with the bottom rail? No, they wouldn't. I think you're thinking of something different than what I'm thinking of. This is what I'm thinking of. Whoops. Come on. Normal extrude. Oh, yeah, that's obviously 1 inch. I just made it an inch. Whoops. Yeah, I'm thinking supporting the stencil frame because Johnny makes a good point. All of the actual stencil forces that you're pressing down on, in theory, will be aimed directly at the board, which is what we want because that's how you get the proper pressure. But we don't want the edge to be able to twist. Your stencil area is 370, 370 rather than the 470, 370. Did I really? I had one job, and I already messed that up. I tried. It doesn't really matter, but for the sake of it, I will. So we could do something like that. Is this to alleviate the PCB mounting plate? The PCB will be a middle leg supporting the stencil sag. Yes. So basically, these would be bottom stops. And this is how our printer, again, I don't have a way to show you real time. This is how our printer works. So the way you do fine-tuning adjustments of, because you have to, so with our printer, when it lowers, you have to, when the stencil lowers or the PCB raises, you have to have a way to adjust to make sure it's perfectly parallel with the PCB. And it has little adjustable screws on all four corners with a rubber stop, and you adjust the height of them. So that's essentially what this will be. So I think this actually is a pretty good solution. So this would just be like the aluminum extrusion, and we could tap the end of it and do the double nut set screw exactly like what the printer over there has. So these will prevent any bending forces, and all of the force from the stencil will be going straight down, which I am really shocked. I know you guys said that this was a big improvement over like the standard, like the wheeled ones, which I've messed with those a couple times, actually fairly recently. These are like ridiculous how strong they are. I'm pretty shocked. I wanted to do something. What was that? Oh, a heat. Yes. 370 by 470. So it would be like this. You know what I should have done? So wouldn't it be a lot easier to just use a heavy PCB mounting plate so it doesn't bend much, then make the stencil holder have an adjustable Z-axis corner? Wouldn't it be a lot easier to just use a heavy PCB mounting plate so it doesn't bend much, then just make the stencil holder have the adjustable Z-axis corners? I got you on the second sentence, but the issue with the bending has nothing to do with the PCB plate bending. It's the fact that this, or it's a little of that, but the other thing that I was thinking of that I didn't mention, and that's what I was kind of alluding to when I mentioned how our printer is keep in mind this stencil foil is 0.12 millimeters thick, so it's able to flex. So if there's nothing supporting the four corners, we're gonna have a gantry holding this. But no, still, this if we support the stencil on all four corners, that allows us to have a cantilevered, like a single axis supporting and lifting the stencil up and down, maybe. So maybe that makes it even easier. I know that was like a few things all at once. The sturdiness of linear rails you described is what I called overkill in last live stream. Yes, that is indeed true. So one thing I just realized that I messed up on is this is not going to be centered here. When we're actually using this where the PCB is going to be over this. And that gives it even more support. And the reason for that is so it can give me the PCB as a little present on the outside. So now's where I get to have fun with the way I did the joints. So let's see if there's any possible way I can fix this. Are we supporting the stencil or the PCB mounting plate? The four pillars are supporting the stencil, where the only thing supporting this is the linear rails themselves. So this makes it so the stencil is super rigid on here without any flex. Again, this is exactly how our printer is, except imagine the stencil is fixed in the The stencil is fixed in the Z direction up and down, and this whole bottom floor goes up and down in the Z direction. And it has 4 corners that touch the PCB to make sure that touch the stencil to make sure it's perfectly parallel. So I think I like this. It mimics how our printer is. So let me see if I can go back and find a way to adjust this to be over at the end. This is going to be even hard to figure out which pieces are... Let me save before I do anything stupid. Oh, nice. I know what that part is. Use the align from the assembly menu. But I already made joints of these. I made them rigid groups. I don't think I can adjust that now, can I? So what I am thinking is, what if I rigid group... Oh, you're saying now. Yes, yes. So use align from the assembly menu. I do not see a line. Let me try my idea first. Why does that say 4? It's in modify. Align. Moves an object where by aligning Symmetry. Ooh, I've never tried that. Yeah, I'll do that instead of what I just did. Align. So, I think I'm don't have Fusion 360. Okay, so let's do this. But can I select multiple? It doesn't let me select multiple. Oh boy. I have no idea what I'm doing. For the sake of time, let me do it with making these rigid groups, because I think I know how to do it that way at least. Yeah, let me just do it this way. I at least know how to do it. So let's try there. And now let's see how bad we just broke everything. Control and select middle point of the hole. Okay. Yeah, I'll take this method. Let's see, did it break anything? Oh, look at this. Did not... Oh. But it didn't save anything because I didn't capture position. Way to go. Oh, boy. Well, at least I know how to do it now. I would like to blame that on a stupid thing with Fusion, but no, that's pretty much operator error. Now position is captured. Now let's see how much this breaks. Nothing? Are we good? We are good. Okay. That is awesome. So let me, since the floor now is going to need to be bigger, let me go back and edit this. I think I'm understanding this reduces the precision required for the Z-axis motion. The support pillar lets you fine-tune Z-axis height and levelness and also pressure on the PCB. Perfect. That's exactly what I'm thinking. And if we want to get... Oh boy. If we want to get really fancy in the future, which this is another thing me and Ahid had talked about, we could have it being like an electromagnet with some sort of top part to help pull it down at the end. I know the stencil is aluminum, but we could have some sort of indexing thing to pull it. Okay. Yeah, I'm fine with it being slid there because that was super, super rough anyway. So let's go back to here and where we captured motion. So let's adjust this. And I know I'm doing this incredibly wrong. Like, I'm not jointing or anything here. I'm just doing it to get concepts fleshed out. We'll obviously have to correct that later. But I just want to make sure everything's on the same page. Well, that one's annoying. Why did it not do that? Oh, because I didn't even align any of this. That's funny. There we go. Okay. So, I would be standing right here. This would be how the printer would be used. So, when you're printing on it, the PCB is back here, and then when it's done, the stencil lifts up, and then it brings out the PCB to you, which means this needs to be on the other side. Oh, look at that. I'm not even rotating on the center point. Okay. So now it would bring the PCB out there, and that's plenty of travel looking at how it is actually. So my only thought here, because the cheapest and easiest way to do the mechanism to hold the stencil would be to have a single linear rail in the back here in the Z direction. That would clamp onto the PCB. It would lift the... Why am I flipping around PCB and stencil so much, man? It would clamp onto the stencil, and it would be able to lift it up and down in the Z-axis. There's no issue with forces downward because we have these posts here. The issue that I can kind of see is, since what I was alluding to with like the electromagnets, these are technically kind of floating, so there's no active force downwards. So when that actuator goes to set the stencil down, if I push this upwards, I can just kind of flop the stencil up and down. So what I'm worried is when I use this and drag the paste across, if I lift up the squeegee, if I bump something, this thing's just going to be so flopping around. So the way to solve that would be, we have a linear rail on the left and a linear rail on the right. So then it's going to be quite rigid, as it's no longer like cantilevered. I think that's probably required, because let me grab one of those stencil sizes and see how it looks. Two options: manually locking mechanisms around the post, or electromagnets near the post pulling the frame down. So, I don't know. These are way more rigid. These are really rigid. I don't know. Maybe this would be strong enough cantilevered. There is zero flex whatsoever here. I don't know if it would be flopping around too much. Yeah, because the problem will be on the mount end, but look at this. That's how all of these are. Oh, maintaining downward force. Yes. Yes. Regardless. Yeah, because that's something that these compensate by having a weight on them. That's right. Or no, the weight helps bring it back up. Never mind. Does anyone use... Yeah, Sion, are you here? How does yours keep the stencil downwards? Or Marius, whoever has one of these. Does the user hold the stencil down? Maybe. Maybe that's what it is. Let me see. It is the pressure from the squeegee, but what I thought you were getting at is the second you let go, there's nothing like holding it down anymore. Let me see how they... Oh, this is one of the super cheap foil ones. This is even cheaper than that one we were looking at. Oh, and look at that. Oh, gosh, that is terrible. How do you make a video showing it like that? Show a close-up of the pads. Nope. Figures. I think nobody cared before this. Yeah, look at his hand. So that's what it is. He kind of holds it down and then lifts it up. Oh, and that's... I guess Sion's not here anymore, but that was one of the reasons he made the vacuum bed, is because it holds the stencil down. So yes, then this is an issue that we need to solve. Yeah, because that was one of the big things. Yeah, check. Oh, check the fourth. That's pretty funny. The fourth video is this. Go figure. Oh, and then part one. Okay, so now let me read back. Two options. Manual locking mechanisms. I don't like that because then you have a electronic system to lower it. Then you have to manually lock it. I don't like that. Or the electromagnets. The problem with the electromagnets, with this part of it, since it's not our own, with what he was talking about, is that would have been on the PCB side with a custom mount. We can't, unless we have a full-length frame. I don't know. Even tiny flex on the supported end. The frame is, I think, aluminum. It's aluminum or stainless. I know it's not ferrous. Before I say something stupid, let me grab a magnet. Yes, non-ferrous. Completely non-magnetic. Okay. So... But if we had two linear rails over here, that still solves it. Because if we had linear rails pulling downward, they're literally right where the PCB is. And the height of those in conjunction with these posts, that should be able to fine-tune it perfectly to where they're perfectly parallel. I mean, it just kind of sucks that for something this simple, we now have 1, 2, 3, 4, 5, 6 linear rails. I think you'd have to have your full stencil surround that is ferrous, then support pillars can have the electromagnets. Yes, that's when I kind of was talking and then stopped. That's what I realized. It would have to have an entire casing around it that is steel that we could clamp to, which, to be fair, that is how our printer is. It has electromagnets that lock it at the end. So it would basically, let me see if I can find, I really wish I could bring a camera over there and just show you what I'm talking about. Actually, maybe there's a YouTube video. Yeah, so you see how, come on, that's not a good picture of it. Oh, speaking of, we were talking about linear motors earlier. All of ASM's new equipment use linear motors, which is so freaking cool. I can't wait till they become a bit more affordable. So yeah, here, the stencil slides in to that track, and then the track is what you clamp down on. You know those spring-loaded gizmos? Gizmos? To hold brooms or similar round sticks. Could something like that be used, where it snaps into place but can also be snapped out? The problem is it's going to be adjustable, because that's the whole point of this. It's not going to be indexing at the same point every time. What's the advantage of linear motors? The TLDR is they have unbelievably fast acceleration, which honestly is the main advantage that they use in pick and places and stuff, because for most other motion controls, like routers, CNCs, all that, it's not so much, and the acceleration isn't as important. But there's some really cool demos. I was trying to find it again the other day. They're able to take, it's a company that sells them. It's basically a linear track like this, but it's with a linear motor, and it's held vertically, and it has a little ping pong ball or some steel little ball, and in a track like, I don't know, like 100 or 200 millimeters tall, it's able to accelerate so fast that it shoots the ball up in the air and then catches it right back. It's really cool. So pretty much all pick and places and everything, that's what they're moving to, but they're so expensive. So, trying to think. And the problem with the little corner thing is the tolerances on a lot of these stencils, especially in the corner, because they wrap foil around them, is pretty terrible. I mean, I guess at this point, what's the big... There's already 1, 2, 3, 4, 5 motors. It's 5 between 6. Are they less precise than ball screws? No. You're using an external encoder anyway, so the accuracy with them is irrelevant. Basically, all it is a brushless DC motor that is unwound, and that's what it rides on. So the fixed magnets are the track, and the part that moves is the powered electromagnet. So you can use, obviously, the feedback in your BLDC drive there, but they have a separate magnetic or optical encoder that it rides on as well. So that's what actually handles the accuracy side. So then, for the sake of this, what if we... Yes, so MSCNC brings up the biggest downfall of them is they have really bad torque compared to a ball screw, because you can't really gear them. The only force is the magnetic force applied with them, which is why they were built for pick and places. Like, pick and place heads don't have much torque, they don't have much force. It's all about speed and acceleration. So it is kind of funny. I don't know how big of a use they're going to have in industry as a whole, because they are very niche-like for a pick and place or stencil printer or stuff like that. But they're really interesting. Yeah, fast, agile, but not very strong. So then let's take this one. Whoops. I guess it's cost difference between 2 linear rails versus 1 linear rail with the electromagnet mechanism. Yeah, I mean, I think at this point it's probably going to be easier to just go with another rail. I mean, I did say I wanted to learn about gantry systems. Why not have all the motors? High RPM spindle, small tool, and you can use linear motors. Yeah, I guess so. But I still don't think the advantages that you're getting from it being mainly the accelerations, I don't think that's really that big of a benefit. Because especially with them being so much more expensive. Oh, I didn't make those fixed. Oh, yeah, I did because I copied from it. Actually, it might be beneficial in modern cutting paths, HSM machining. I do not know. Relatively light cut, but very fast. Yeah, I mean, that would be a use case for sure. Instead of heavy and slow. I only know about heavy and slow machining. But yeah, someone earlier in the Discord was talking about building a linear motor. And what's funny is I was actually just talking about that with somebody the other day, that would be a really fun project to do. I think it'd be really, really hard though. Because you're having to custom make a BLDC drive in a way that BLDC motors don't exist. Linear motor railgun, yes, that's in a way kind of what they are, except opposite, because the motor part is the one that's moving instead of the other way around. So now let's make these in line. No precision positioning is required. Okay. Just requires a small nuclear reactor. That is what's always funny, is it's like they've had these like the crazy railguns, they've had all this crazy stuff, and it's like the only ships that actually have power for it are the nuclear powered, like the aircraft carriers and stuff. Because it's wild how much power those things take. Okay, so other than this being a disgusting amount of motors, I think this works. I think you might want to rotate those Z-axis rails. Oh. Yeah. Too late. Yes, you're obviously right. Minor issue, as MS says about the nuclear reactor. So other than that, does anyone see any issues here? So Z-axis lifts the stencil up. These will be the 880 or 8080, whatever, aluminum extrusions. That'll be here, here, and then probably one across to strengthen, one across here, kind of a little box. And And on the top of these, there will be a tapped hole, which will have an adjustment set screw, which will adjust the parallelism of the stencil and the PCB, which will be in conjunction, or I guess that sets it. These don't actually set it whatsoever. These just have to be set so they apply some pressure on the little adjustments. So that handles the z-axis, and then for our holder, we'll have some sort of aluminum plate here with some sort of little nuggets that somehow hold the PCB. And this gives us our rotation. This gives us our X movement. This gives us our Y movement. And we have plenty of motion here to put the PCB there, push a button, and it draws it back out, or draws it back into here. I think you might want that I was thinking about the cost of the z-axis rails, but you don't need much motion range at all, do you? So they can be short. Oh, good point. So you know what we can do is we use the 100s and then mount them to the 888, whatever aluminum rails, and then they can be really short. Good point. And a link between, oh, how about adding 2 more posts in the middle? As it is now, stencil might get bent. Good point. Yeah, so it should probably be 3. The problem with that is then we're adjusting. I'll be right back. I'm going to see how many standoffs that has, because if we have 6, that's going to make parallelism very difficult to set. Okay, I took some pictures. I'm going to share in the Discord, and I'll explain what they are. One thing to look out for is that I noticed the ball screw end plates extend past the aluminum extrusion very slightly, which might make mounting the overall main base plate a little tricky. One thing to look out for is I noticed the ball screw end plates. Oh, see ya, Marius. Glad you were able to join. One thing to look out for is the end plates extend past the aluminum. You're going to have to explain me that again. I do not follow. Okay, so basically, this is the conveyor which feeds the PCB in. So the PCB is clamped right here. So it's held on this conveyor and this conveyor. The stencil is up here, and again, it does not move other than X, Y, and theta adjustment. So it does not move in the Z-axis. So once the PCB is here, it's clamped. The camera, which you can see the reflection of, moves, which is actually right here. So it moves, checks the fiducials, everything is good. It adjusts the stencil, X, Y, theta, so it's aligned. Then all of these posts are to hold the PCB against the printer. So this whole plate lifts up and is hit by the 4 end stops. So there are, oh, my finger's in front of the lens. Rookie move. So 1, 2 on the left side and 1, 2 on the right side. So you can adjust this as it pushes up. This stops right here, which adjusts how evenly these stakes or these posts hit the entire PCB or obviously panel. So by adjusting these, you adjust how much the pressure is applied in whatever orientation. So yes, it's what I thought. It only uses 4, 1 in each corner. So I get what you're saying about it being unsupported here, but I don't think we have to worry about this flexing because this thing is super rigid. We just have to worry about it, like you said, the mounting being able to be loose. Look at your physical parts. See if the aluminum extrusion fits flush. Oh, now I get what you mean. Yeah, they do. They're perfectly flush. Does it not look like that in the picture? Or is yours? Because you have some. Yeah, and it's completely flush here. If that's what you're talking about. Yeah, because it's perfectly flat on the table. If that's what you were meaning. I'm assuming it is. Mine were a little different. That's what I was talking about. Gotcha. Okay. I was so confused. Okay, so then does anybody see any or have any issues with how this is mounted? Or not how this is mounted. The whole concept here. With a sturdy frame, those small stepper motors might actually stall before they apply any serious bend to the stencil frame. Yeah, I think so. I personally cannot see any issues here. And what's also cool about this setup is if this does work really well somehow and I'm happy with how everything is set up, there's nothing to say, and this is what Marius is working on, is there's nothing to say that you can't just add on an extra y-axis on the top that holds the squeegee, so you could make it do an automatic squeegee on here. I just don't see that ever being useful because if I'm doing a one-off prototype, it's going to be way faster to just do it by hand, and it's going to use a lot less paste. Were you thinking of something like an A-frame that overarches the XY system that has the Z-axis mounted the inside of the A-frame? I'm glad that question wasn't for me because that makes absolutely no sense for me. To me. Yeah, but I think so. Then the only oh no, I don't have the page where I got this from. Does anyone remember what website that was from? Maybe it was on this. Nope. So to recap, you'll load the stencil, you load the PCB from the front, PCB gets moved to the back, and then you align it manually via camera at first, was it? So at first, it's probably going to just be by my eye, at least at the start. So it'll lower down the stencil to be like a millimeter or a half a millimeter above the PCB, so I can look down at the pads, and then using whatever, I was thinking like an arcade joystick, then I adjust everything. Then you hit foot switch or whatever, stencil is lowered, you do the paste step, and stencil is lifted, and PCB goes out. Yes, that is correct. So yeah, I don't know where, let me see, I'll just go to my history and find it. Yep, it was Sureline. So then this handles that. What size is the stepper motor? Camera just to get angle correctly. Yes. So that's what, if I ended up adding a camera, it would be just directly down to look at the apertures, which wouldn't be expensive or difficult. NEMA 23. What size motors are these? I have no idea what size motors those are. I shared the Amazon link. It probably shows. NEMA 23. Well, that's convenient. So the exact same driver and the exact same everything can be used for all of these. So they're all NEMA 23s. It does kind of suck because now I literally have to have whatever I'm going to use to control these. Control 1, 2, 3, 4, 5, 6 different motors. And since most of those motion controllers, if you get something set up specifically for it, they're an axis, so X, Y, Z, theta, or whatever, and 6-axis probably isn't going to be that common. But what I'm thinking probably makes sense is just use single stepper motor drivers and have them controlled by whatever, as long as it can talk to enough of them. For 2 amp current motors, I would guesstimate torque at about 2 Newton meters. Should be plenty enough. Sounds good to me. GRBL running on Arduino with a stepper board is really cheap. Okay. Yeah, because obviously I don't want to do a custom PCB for this, at least not until there's validity in that this system's actually worthwhile. But yeah, I think then we're at a good stopping point. Oh, there is one issue with this design. I still think we're at a good stopping point, but what do you see as the issue? But yeah, I'm thinking next step, just grab, remember when you notice there are no motors? Oh, but does that affect anything? How does that affect anything though? Because how we were saying these don't need that much travel, these would just be mounted to the support 880 extrusions. Yeah, Z-axis mounted where the motors would be. But they're going to be mounted on this track to the aluminum extrusion. So I think that works fine. They're not going to be touching the ground anymore because we'll just be using the 100 millimeter. So they'll be higher. Yeah, that should be fine. Because I don't think the height, question if they're not too high then. I don't know where my calipers are. But no, they're not going to be too high because they're only, what? And the motor could be on top. Yeah, these things aren't that big. They're probably like 4 inches. So that would only put them about here. But yeah, worst case, the motor just goes up top because with the 100 millimeter rails, they're only going to stick up like to right there. Yeah, but then mass is high on top. Would be better to keep it near the base. I don't know, man. They seem pretty sturdy even, because if they're mounted onto that frame, I don't think that's going to be an issue. But yeah, either way, I think that's pretty easily remediable. Sure, but the rail sure doesn't matter that much. Yeah, that's what MS and CNC just said. Well, cool. So yeah, I think we're at a pretty good stopping point. So the next step, I'm going to pick up one of these rotational gizmos. I'm taking a Heed's term. I'll pick up one of the rotational plates, and once that is in, then the next stream will be to actually start properly modeling this. And what's cool is, other than the plates here, everything else on the motion side is going to be off the shelf, because all of this is going to be the aluminum extrusion. The PCB plate will need to be custom, but I'm not including that in this discussion, because that's going to be separate to the motion side, so I'll figure that out later. But yeah, I think, do you have access to any manufacturing capacity? Oh yeah, we've got drill presses and stuff up front. Nothing like crazy, but yes, we can at least drill straight holes. And then just using like an online laser cutting service for if we need aluminum or something, I think that works pretty good. And like what, send, cut, send to do anything else. Chances that drill press would be enough. Yes, I agree with you there, because that doesn't have to be any sort of accurate compared to anything else. But cool. Yeah, so I will let you know in the Discord when I get this stuff in. And then, are there any electronics projects in the pipeline? There are. I have a very, very long list of videos I want to do, because obviously I need to get back on schedule doing the normal style of videos and not just this. It's just work this year has been, as it seems like with all other design shops somehow, has been like by far the busiest year ever. So I just have been really struggling to do this stuff on top of it, which I know I really need to. But yes, there are plenty planned, and hopefully coming up I'll be able to get some of them going, because I have a bunch of new EMC equipment. I have a couple TEM cells, more shielded tents and bags, a lot of stuff. So yes, definitely want to start doing some more stuff with that, which will be coming up at some point. So sweet. So like I said, we'll keep everyone posted with when I order stuff, and then let you know when the next stream is. But until then, just catch you all in the Discord, and I will see you guys in the next stream. I appreciate everyone for tuning in. Have a good one, guys.